Section 210.12b of the 2008 National Electrical Code requires that all 15 amp and 20 amp branch circuits supplying bedroom receptacles be protected by arc fault circuit interrupters, often referred to as AFCIs. Furthermore, Section 410.73 permits luminaires, which are essentially light fixtures, that are installed over bathtubs or showers to be supplied by a branch circuit that is protected by an AFCI. There's an important exception to consider. Lighting outlets, other than receptacle outlets, that are installed on a branch circuit supplying bathroom receptacle outlets and protected by AFCIs are not required to be served by supplementary overcurrent protection. This means that if your bathroom lighting and receptacles are already protected by an AFCI, you don't need to add another layer of overcurrent protection specifically for those lighting outlets. Understanding the historical context of these requirements is crucial. In the 1999 National Electrical Code, there was no mandatory requirement for AFCIs in bedrooms. Therefore, situations where bathroom fixtures and exhaust fans share a branch circuit with bedroom receptacles were not explicitly addressed in that earlier version of the code. However, the 2008 NEC introduced significant changes. Under the 2008 NEC, bedroom receptacles and bathroom lighting outlets are allowed to be in the same branch circuit that is protected by an AFCI. This represents a shift in the code's approach to electrical safety in these areas. The exception found in Section 410.73 is particularly important. It specifically allows lighting outlets located over bathtubs or showers to be on AFCI-protected circuits. This clarification ensures that these potentially hazardous locations receive the necessary protection against arc faults. Let's consider a practical example. If you have bathroom fixtures and an exhaust fan on the same AFCI-protected branch circuit as the master bedroom receptacles, this configuration is generally permissible under the guidelines of the 2008 NEC. The code recognizes that these areas can be served by a single AFCI device, simplifying the wiring and protection scheme. It is important to consult the most recent edition of the National Electrical Code and any applicable local amendments. The electrical codes are subject to updates and revisions, so staying current with the latest regulations is essential for ensuring safe and compliant electrical installations. When working with electrical systems, it is always advisable to consult with a qualified and licensed electrician. Electrical work can be dangerous, and a professional electrician has the training and experience to perform installations and repairs safely and in accordance with all applicable codes and regulations. In summary, understanding the specific requirements and exceptions related to AFCIs in bathrooms and bedrooms is crucial for ensuring electrical safety. The 2008 NEC provides clear guidelines on this topic, allowing for the sharing of AFCI protection between these areas under certain conditions. Always refer to a latest edition of the NEC and consult with a qualified electrician for any electrical work. This discussion is intended for informational purposes only and does not constitute professional electrical advice. Always consult with a qualified electrician before undertaking any electrical work. The purpose of arc fault circuit interrupters, or AFCIs, is to protect against fires caused by arc faults. Arc faults are unintentional electrical discharges that can occur when damaged or deteriorated wiring creates a pathway for electricity to jump from one conductor to another. These arcs generate intense heat, which can ignite nearby combustible materials and lead to a fire. AFCIs are designed to detect the unique characteristics of arc faults and quickly interrupt the flow of electricity, preventing the arc from escalating into a fire. Unlike traditional circuit breakers, which primarily protect against overloads and short circuits, AFCIs are specifically designed to detect arc faults. They use sophisticated electronic circuitry to analyze the electrical waveform and identify patterns that are indicative of arcing. When an arc fault is detected, the AFCI trips, cutting off the power to the affected circuit. There are two main types of AFCIs: branch/feeder AFCIs and outlet circuit AFCIs. Branch/feeder AFCIs are installed in the electrical panel and protect the entire branch circuit. Outlet circuit AFCIs are installed at the outlet and protect the wiring downstream from that point. AFCIs are required in many areas of the home, including bedrooms, living rooms, dining rooms, and family rooms. The specific requirements for AFCI protection vary depending on the addition of the National Electrical Code and local amendments. In general, AFCIs are required on branch circuits supplying receptacles in these areas. AFCIs are an important safety device that can help to prevent electrical fires. If you are unsure whether your home has AFCIs, it is best to consult with a qualified electrician. The National Electrical Code, or NEC, is a widely adopted standard for safe electrical installation and maintenance. It is developed and published by the National Fire Protection Association, or NFPA. The NEC is updated every 3 years to reflect the latest advancements in electrical technology and to address emerging safety concerns. The NEC is not a law itself, but it is often adopted by state and local jurisdictions as part of their building codes. This means that electrical installations must comply with the NEC in order to be considered safe and legal. The NEC covers a wide range of topics related to electrical safety, including wiring methods, overcurrent protection, grounding, and equipment installation. It provides detailed requirements for electrical systems in residential, commercial, and industrial buildings. The NEC is organized into chapters, articles, and sections. Each section addresses a specific aspect of electrical safety. For example, Article 210 covers branch circuits, while Article 250 covers grounding and bonding. The NEC is a complex document, but it is essential for anyone involved in electrical work. Electricians, contractors, inspectors, and engineers all rely on the NEC to ensure that electrical systems are installed and maintained safely. The NEC is not intended to be a design manual, but it provides a framework for safe electrical design. It is up to the qualified electrical professional to apply the NEC requirements to specific projects and ensure that the electrical system meets all applicable codes and standards. The NEC is a valuable resource for promoting electrical safety. By following the NEC requirements, we can reduce the risk of electrical fires, shocks, and other hazards. The proper installation and maintenance of electrical systems are critical for protecting people and property. Always consult with a qualified electrician before undertaking any electrical work. Electrical work can be dangerous, and a professional electrician has the training and experience to perform installations and repairs safely and in accordance with all applicable codes and regulations. In addition to the NEC, there are other standards and regulations that may apply to electrical installations. These include local building codes, state electrical codes, and federal regulations. It is important to be aware of all applicable codes and standards before starting any electrical work. The goal of electrical codes and standards is to ensure that electrical systems are safe and reliable. By following these codes and standards, we can create a safer environment for everyone. Arc fault circuit interrupters, or AFCIs, are designed to detect and protect against arc faults, which are dangerous electrical conditions that can lead to fires. There are several types of arc faults: series arc faults, parallel arc faults, and ground arc faults. A series arc fault occurs when there is a break in a single conductor, such as a frayed wire or a loose connection. A parallel arc fault occurs when there is a short circuit between two conductors. A ground arc fault occurs when a conductor comes into contact with a grounded surface. AFCIs are designed to detect all three types of arc faults. They use sophisticated electronic circuitry to analyze the electrical waveform and identify patterns that are indicative of arcing. When an arc fault is detected, the AFCI trips, cutting off the power to the affected circuit. AFCIs are an important safety device that can help to prevent electrical fires. They are required in many areas of the home, including bedrooms, living rooms, dining rooms, and family rooms. The specific requirements for AFCI protection vary depending on the addition of the National Electrical Code and local amendments. In general, AFCIs are required on branch circuits supplying receptacles in these areas. If you are unsure whether your home has AFCIs, it is best to consult with a qualified electrician. Regular testing of AFCIs is recommended to ensure that they are functioning properly. Most AFCIs have a test button that can be used to simulate an arc fault and verify that the device trips. It is important to follow the manufacturer's instructions when testing AFCIs. AFCIs are a valuable addition to any electrical system. They provide an extra layer of protection against electrical fires and can help to save lives. When selecting an AFCI, it is important to choose a device that is listed by a recognized testing laboratory, such as Underwriters Laboratories or all. This ensures that the AFCI has been tested and certified to meet safety standards. It is also important to choose an AFCI that is compatible with the existing electrical system. Consult with a qualified electrician to determine the appropriate type of AFCI for your application. AFCIs are available in different amp ratings and voltage ratings. Be sure to select an AFCI that is rated for the circuit that it will be protecting. The installation of AFCI should be performed by a qualified electrician. Improper installation can create a safety hazard. The electrician will ensure that the AFCI is properly wired and grounded. They will also test the AFCI to verify that it is functioning correctly. The cost of AFCIs has decreased in recent years, making them more affordable for homeowners. The added safety and protection that AFCIs provide make them a worthwhile investment. Consider upgrading your electrical system to include AFCIs in all required areas. This can significantly reduce the risk of electrical fires in your home. Remember to consult with a qualified electrician for any electrical work. Electrical safety is paramount, and a professional electrician can ensure that your electrical system is safe and up to code. The use of AFCIs is just one aspect of a comprehensive electrical safety plan. It is also important to have properly installed and maintained smoke detectors and carbon monoxide detectors. These devices can provide early warning of a fire or carbon monoxide leak, giving you time to escape safely. Regularly inspect your electrical cords and appliances for damage. Replace any cords that are frayed or cracked. Unplug appliances when they are not in use. Avoid overloading electrical circuits. This can cause the wires to overheat and create a fire hazard. Be careful when using extension cords. Do not run extension cords under rugs or furniture. Do not use extension cords as a permanent wiring solution. Have your electrical system inspected by a qualified electrician every few years. This can help to identify potential problems before they become a safety hazard. Educate yourself and your family about electrical safety. Learn how to recognize and avoid electrical hazards. By taking these precautions, you can significantly reduce the risk of electrical fires, shocks, and other hazards. Electricity is a powerful force that can be dangerous if not handled properly. Always exercise caution when working with electricity. If you are unsure about any aspect of electrical safety, consult with a qualified electrician. They can provide you with the information and guidance you need to stay safe. Electrical safety is a shared responsibility. We all have a role to play in preventing electrical accidents. By following safe electrical practices, we can protect ourselves, our families, and our communities. The National Electrical Code is a living document that is constantly being updated to reflect the latest advancements in electrical technology and to address emerging safety concerns. It is important to stay informed about the latest changes to the NEC. The NFPA offers a variety of resources to help you stay up to date on the NEC, including training courses, publications, and online forums. Consider attending an NEC training course to learn about the latest changes to the code. This can help you to ensure that your electrical work is safe and compliant. The NEC is a valuable resource for promoting electrical safety. By following the NEC requirements, we can reduce the risk of electrical fires, shocks, and other hazards. The proper installation and maintenance of electrical systems are critical for protecting people and property. Always consult with a qualified electrician before undertaking any electrical work. Electrical work can be dangerous, and a professional electrician has the training and experience to perform installations and repairs safely and in accordance with all applicable codes and regulations. In addition to the NEC, there are other standards and regulations that may apply to electrical installations. These include local building codes, state electrical codes, and federal regulations. It is important to be aware of all applicable codes and standards before starting any electrical work. The goal of electrical codes and standards is to ensure that electrical systems are safe and reliable. By following these codes and standards, we can create a safer environment for everyone. The evolution of arc fault circuit interrupter technology has been remarkable. Early AFCIs were relatively simple devices that were primarily designed to detect parallel arc faults. However, as technology has advanced, AFCIs have become more sophisticated and are now capable of detecting a wider range of arc fault types, including series arc faults and grand arc faults. The development of combination AFCIs, which provide both arc fault and grand fault protection, has further enhanced electrical safety. These devices offer comprehensive protection against a variety of electrical hazards. The increasing adoption of AFCIs in residential and commercial buildings has significantly reduced the number of electrical fires. Studies have shown that AFCIs are highly effective in preventing fires caused by arc faults. As awareness of the benefits of AFCIs continues to grow, it is likely that they will become even more widely used in the future. The future of AFCI technology is promising. Researchers are working on developing even more advanced AFCIs that can detect arc faults with greater accuracy and speed. These next-generation AFCIs may also be able to provide additional features such as real-time monitoring of electrical circuits and remote notification of arc fault events. The ongoing development and refinement of AFCI technology will continue to enhance electrical safety and protect people and property from the dangers of arc faults.